Okay, welcome back, Wolfpack. We are going to start the next section of our dilations video. Again, please make sure you are being respectful for our guest teacher today. I want an excellent report from him or her. So, example number 2. We've already done the first part of our notes. We did example 1. We found the center of dilation and the scale factor. So now we're going to tell whether each dilation will result in a reduction or an enlargement. Then we're going to find the coordinates of the image using the given scale factor. So, letter A says it's going to have a scale factor of 2. Well, if you look back at the first page of notes, it says that if you're multiplying by a number that's less than 1, it'll be a reduction. If you're multiplying by a number greater than 1, it'll be an enlargement. So a scale factor of 2, 2 is greater than 1, so that's going to be an enlargement. Now to find your new coordinates, you take your pre-image coordinates and you multiply each of them by the scale factor. So 2 times 2 is 4. 0 times 2 is still 0. 0 times 2 is still 0. Negative 2 times 2 is negative 4. Negative 2 times 2, negative 4. 1 times 2 is 2. 1 times 2 is 2. And 2 times 2 is 4. There are our new coordinates. And it doesn't say to do this, but let's go ahead and graph it and see what that looks like. So we have 4, 0. We have 0, negative 4. Negative 4, 2. And 2, 4. So there's our new image. I should say there's our image. And what do you know? It does look like it's double the size of our pre-image. Okay? And excuse me, if the music comes on, I will try to pause it as quick as I can. Letter B, scale factor of 1/4. Well, 1/4 is less than 1, so that means this is going to be a reduction. Everything is going to get smaller. So reduction. So 4 times 1/4 is 1. 8 times 1/4 means 8 divided by 4, that's 2. 6 times 1/4 is 6 over 4, which reduces to 3 over 2, or 1/2. And again, 6 times 1/4 would also be 3/2. I said 1/2, I meant 3/2, or 1.5. Again, 6 times 1/4 is 3/2. 4 times 1/4 is 1. 1 and 1. Okay, and so 4 times 1/4 means 4 times 1 is 4, divided by 4, which 4 divided by 4 is 1. That's how I get that. Okay, 8 times 1/4 is 8 times 1/4. 8 times 1 is 8, divided by 4. 8 divided by 4 is 2. But hopefully we feel comfortable with multiplying by fractions, especially when the numerator is just 1. Okay, so let's just plot this just to see how we did. 1, 2. 3 has 3/2. That means 1.5, 1.5. It's going to be right about 1.5. It's going to be nice and small. 1.5. 1.5. It's right about here. Okay. 1.5, 1. It's right there. And 1, 1 is right here. And as you can see with my fat smartboard pencils.
Would the following teachers please report to Skype's office?
Sorry about that. As I was saying, as you can see, oh, great. And I should have timed that better. My apologies. But anyway, as you can see, my smartboard pen is nice and fat, so it's hard to make it nice, clean lines. But you can see that shape looks like the same shape, and it is 1/4 of the size. Example number 3. You work at a photography store. We really don't have those now, but there used to be stores where you'd actually go and like get your pictures developed, and they'd actually print them out for you. It's a photography store. A customer has a picture that is 4.5 inches tall. The customer wants a reduced copy of the picture to fit a space of 1.8 inches tall on a postcard. What scale factor should you use to reduce the picture to the correct size? So scale factor, look back at the beginning of these notes, is image over pre-image. Well, if it is 4.5, that means it's the pre-image. It's what it's starting as. It needs to be 1.8. Okay? So 1.8 divided by 4.5, if you plug it into your calculator, it would become 0.4. So our scale factor is 0.4. A scale factor does not have to be big and scary. It's simply the size of the image, the length of one side of the image, divided by the length of one side of the pre-image. So I'm going to turn the page to example 4. Find a sequence of similarity transformations that maps PQRS to TUVW. Write the coordinate notation, which is the coordinate rule for the sequence. Now, the one thing I see here is that there's a dilation that happened. And I want you to write in your margins to dilate first. Before you move anything, make it the right size. And I've talked about this already, so hopefully that's not news to you guys. So the first thing I see is that I need to figure out the scale factor, so I can dilate it first. I see that it was PQRS, so PS was 3, that's the pre-image, and now WT, which is what it's corresponds to, is 1. So my scale factor is 1/3. Okay, my scale factor is 1/3. So, coordinate notation. You always start with x, y. And then we're going to write 1/3 x, 1/3 y. And actually, I'm probably going to run out of room right here, so I'm going to move that down. I'll dilate first, 1/3 x, 1/3 y. That's my dilation. And then I had to figure out, after that happened, what else happened. So what I'm going to do is we're going to need to go ahead and find the coordinates of P, Q, R, and S. Okay, so I'm going to scroll this down just a little bit. Hopefully you guys can still see. Go ahead and write down P, Q, R, and S. I want you to pause the video and I want you to write down the coordinates of P, Q, R, and S. Okay, you should have written down that P was at 3,3, Q is at 3,6, R is at 9,6, and S is at 6,3. Excuse me. Then the first thing that we did was we dilated it. So that means we multiplied everything by 1/3, or you could say we divided it by 3. And let me change the pen color. There we go. So 3 divided by 3 is 1, 3 divided by 3 is 1. 3 divided by 3 is 1, 6 divided by 3 is 2. 9 divided by 3 is 3, 6 divided by 3 is 2. And 6 divided by 3 is 2, 3 divided by 3 is 1. So I'm going to plot those points to see where it puts us. So I have 1, 1. I have 1, 2. I have 3, 2. And I have 2, 1. There's my shape. Okay. Again, mine's a little off because my pen is nice and big and fat. But you guys get the point. Here we go. Okay. So now that we've done that, how are we going to get it to map directly on to TUVW? Well, it wasn't translated because it's not facing the same direction, and it wasn't rotated. I could see that it was reflected. It's a simple mirror image. They are symmetrical of each other. So was it reflected over the x-axis, or was it reflected over the y-axis? It was reflected over this way. It was reflected across the y-axis. So the rule for reflecting over the y-axis is that y gets to stay the same and x gets a new sign. So this is the coordinate notation for what happened. I dilated first, and then after I dilated and got it the right size, then I was able to easily see that it reflected. But if you were to reflect this first and then try to dilate, you might end up having to move the shape again, which is why I suggest making it the right size before you do anything else. We're going to stop right there, and we will pick this back up in a few minutes.